Hi everyone, this video is an exercise 14F question 1. So we want to solve these equations using logs. And in this question, I'm going to do parts A, D, F, and H. Because basically for all of them, you just apply the same technique. So in part A, we have 2 to the power of x is equal to 75. Right, so Um, the way that you can solve these equations is just by taking the log of both sides. And the only thing that here we can think about is that what should be the base of the log. And the answer is actually it can be anything, really. Because you might be thinking that, okay, that since here we have 2, then the base of the log also has to be 2, so that log base 2 of 2 is obviously equal to 1, and that cancels out, and etc. While that's probably the maybe sort of the cleanest method, the one that gives you easier calculation, you can still use other bases as well. So on purpose, I'm going to solve the first one with the two methods, basically, one with base 2 and the other one with another base, so that you can see that it doesn't make a huge difference. So for the first one, we can first start by taking log base 2 of both sides. So since this is an equation, we apply that to both sides. So for the left hand side, we'll have log base 2 of 2 to the power of x, and right hand side log base 2 of 75, right? Okay, so at this point, as we said, this part that is log base 2 of 2 is just 1, obviously. So and then remember that we can bring this power just outside of the log, so we'll just get x from the left hand side, and the right hand side is just log base 2 of 72. And since we can give the answer to three significant figures, then this is just equal to 6.23. And just showing you with another method that we take another base, basically. So in this case, let's just take log of both sides. When we say also just taking the log, we usually mean when base is 10, but again, it depends on the context, because in some textbooks it's used for another base, which is the natural log, but that's not in A level. In A level, when they say log, they just mean that it's base 10, like a default value. And even on calculator, when you just press log without putting the base, then that just means base is 10. So we'll take the log base 10 on both sides, and this is the second method, by the way. So the second method, and here is also log base 10 of 75. Now here, remember that using the power law, so we can rewrite this as x log base 10 of 2, or just log 2, is equal to log 75. Therefore, x is equal to log 75 divided by log 2. And here we use calculator, and calculator again gives us 6.23 to three significant figures. And as you can see, it made no difference. The only difference is that if you don't want to use calculator for some parts, then when you have the same base, that's easier. But even in this case, for the final step, if you want to give your answer as a decimal, you still need to use calculator. Right, so with that said, now let's do part D. And in part D, we have 4 to the power of 2x is equal to 100. So I'm going to take the log base 4 of both sides. So we'll have log base 4 of 4 to the power of 2x is equal to log base 4 of 100. And this is equal to, so the left hand side, just log base 4 of 4 is 1, so we get 2x is equal to log base 4 of 100. And so we divide both sides by 2, so we have x is equal to log base of 100 divided by 2, and the answer is equal to 1.66 to three significant figures. Now for F, we have 7 to the power of 2x minus 1 is equal to 23. So again, we take logs of both sides. So in this case, again, just to show you that doesn't make a difference here, I'm just going to take the natural log of both sides. So we'll have len of 7 to the power of 2x minus 1 is equal to len 23. So this becomes, again, the power can be written outside as a coefficient of log. So 2x minus 1 len 7 is equal to len 23. Now we divide both sides by len 7, so we have len 23 over len 7. And now we can add 1 to both sides, so we have 2x is equal to len 23 over len 7 plus 1. And now let's divide by 2, so len 23 over 2 len 7 plus 1 over 2, and the answer is equal to 1.31. So yeah, as you can see, it can make calculation a bit messier when the base number isn't the same as here, because when it's the same as this number, then we'll have one cancellation at least. And finally h, which is very similar to f. So in h we have 2 to the power of 3 minus 2x is equal to 88. Okay, so again, this in this case, I'm going to take the log base 2 of both sides. So log base 2 of 2 to the power of 3 minus 2x is equal to log base 2 of 88. Right, so again, the left hand side will have a cancellation of log. So we get 3 minus 2x is equal to log base 2 of 88. And then can do 3x is equal to log base 2 of 88 minus 3. And finally, x is equal to half log base 2 of 88 minus 3 over 2. And finally, this is equal to minus 1.73.